first of all. That's the most important thing. So if we have an area to determine, let's say this is function g of x, and let's say this is function f of x, and I'm able to determine these points of intersection, let's say between A and B, and I'm asked to find this area. How do I find it? Very simple. So the area enclosed, this area, is the integral from A to B, from the point of intersection to the point of intersection, from above minus below, of course, dx. So in this case, the area will be the integral from A to B. Above is f of x, oops, minus below is g of x dx. So coming back to the graphs that we are given, so let's select anything from 11 through 14. 11 looks interesting, but it's up to you. You can choose, or I will choose. Okay, in that case,
We'll do 12.
okay, we'll do 12. Okay, so in 12, you notice we are given the points of intersection, we are given the graphs, and it's very clear that this shaded area is made out of two pieces, independent pieces. This piece between x equals -5 and x equals -1 is one piece. The other one is between x equals -1 and x equals 3. We are given the points of intersection. They are here. -5, -17, -1, -1, 3, 15. So, the first area, see, F is above, G is below. But in the second area, the second piece, G is above, F is below. So let's start. Can anyone give us what do you think we're going to have to write? It's okay if you're wrong. So the first area is between which and which? So it's the definite integral from anyone?
-5 to -1.
Exactly. X equals -5 to x equals -1. From above. Above is f. I have to read f. This is f. So x cubed plus 3x squared minus 9x minus 12 dx plus. Can anyone else give us the second area? Please. Anyone will try? Would like to try the second area?
Is it just the g of x?
But the area has to be above minus below. So it's a definite integral from
-1 to 2.5.
-1 to 3, right? It's right here.
Oh, sorry.
Good. -1 to 3. Good. What is above? Oh, I didn't finish. I'm so sorry. I'm jumping ahead. So I haven't finished here. So it's minus the below. 4x plus 3. I said that, but I didn't put it in. Sorry about that. Good. We are now finally at the second piece. Between -1 and 3, what is the above? Now the above is 4x plus 3. And I have to subtract the below. Now the below is x cubed plus 3x squared minus 9x minus 12 dx. So this was above and this is below. This was above for the second piece and this was below. Above minus below. above minus below. Now I have to simplify as much as possible before I determine the integrals. So the integral from -5 to -1, x cubed plus 3x squared minus 9x minus 12 minus 4x minus 3. Remember? Easy to forget. So x cubed plus 3x squared minus 9x minus 4x, negative 13x, negative 12 minus 3, negative 15 dx. This integral will give us the area that is the first piece. Now I have plus the integral from -1 to 3. So now let's see. Negative x cubed, I always put it in descending order, always in descending order. Negative x cubed will be the first one, negative 3x squared will be the second one. Positive 9x with positive 4x is positive 13x. Positive 12 plus 3 is positive 15 dx. They are completely cleaned up and ready. So, equals. Any questions so far? Anyone? Let's stop for a moment, see if you have any questions. Anyone? Any questions? Any questions? Okay, then we'll continue. Which function prime is x cubed? So let's determine this quickly. Anyone, please? Which function prime is x cubed?
1 over 4x to the 4th.
You mean x to the 4th over 4. Perfect. Plus 3. Which function prime is x squared?
Is it x to the 3rd over 3?
Excellent. Minus 13. Which function prime is x?
X squared over 2.
Very good. Which function prime is negative 15?
15x.
That's it. Done. The same thing here. Same answers. Different symbols. Different signs. X to the 4th over 4 minus 3x cubed over 3 plus 13x squared over 2 and plus 15x. Excellent. Good. So now, careful. We have to plug in -1 and then we subtract when we plug in -5. We plug in 3 and then we subtract when we plug in -1. I'm going to write them, but it will take me a while to calculate all this. So I'm going to do it with a calculator with your permission. So I plug in -1, I get 1/4. I plug in -1, I get -1. I plug in -1, I get negative 13 halves. I plug in -1 plus 15. Minus, don't forget to put the minus when you plug in -5. So I have 5 to the 4th over 4 because it's an even power. That sign will not change. And then minus 5 to the 3rd, -5 to the 3rd is 125. Here I have minus 13 times 25 divided by 2. And then plus -5 times -15 is 75. Plus, I plug in 3, negative 81 over 4, minus 27 plus 13 times 9 over 2, plus 15 times 3, that's 45, I should have written it, minus, when I plug in -1, it's -1/4, plus 1, plus 13 halves, minus 15. It will take me quite a while to calculate all those, so with your permission I'm going to just jump to the calculator. So we go to math and number 9, and then I said I need a second integral. Of course this, I don't understand why the dx doesn't pop up, there is no other option, so, but I didn't mean that. Easy. Okay. So, the first one. From -5 to -1. And x cubed plus 3x squared plus 3x squared and minus 13x minus 15. Okay, jump to the second one. This is from -1 to 3, and that was -x cubed, and then minus 3x squared, and plus 13x plus 15. Yes, I accept the same thing on your next test and the final exam. Write down the numbers as I have them here. You don't have to calculate. I'm not testing you on arithmetic, so you can do this with a calculator. Okay, 128, nice. So the area enclosed, which area? This. All this is 128 units squared, whatever, it doesn't matter, okay? Now, the last part here is when we are not given the graph, or the graphs, I should say. We're not given the graphs, we're asked to graph. So you'll be asked, number one, to graph correctly both graphs, or 3 graphs, whatever they are. Shade in the area, find a point of intersection, and then find the areas using definite integrals. So, let's go ahead and choose something that will not require an hour. Like for example 17. 17 appears to be a straightforward example. So y equals x plus 2 and y equals x squared. Okay, so I'm going to stop sharing. So here we're asked, number 1, graph. Number 2, although this is not specified, we're asked to find the area enclosed. So these are the steps. First we have to graph both. Then you have to find the points of intersection. And number 3, shade in the area enclosed. And number 4, find it. Find the area. All these are understood. If you don't graph, you can get the full points. If you don't find the points of intersection and you don't show the algebra, you cannot get full credit. So please understand these are the 4 steps required. Simple situation, because this is linear and this is quadratic. We've done this at the beginning of the class. So then, first I will find the points of intersection. When I set them equal to each other, when I set x plus 2 equal to x squared, or vice versa, x squared, or move everything to one side, minus x minus 2 equals 0. Yes, you can use the apps to solve this, but this is too easy. It's x minus 2 and x plus 1 when we factor it. So I know that the points of intersection will have x equals 2 and x equals -1. Now, if you'd like, you can determine, and we should, you can determine the y coordinate. When we plug in 2 here, 2 squared is 4. And when we plug -1 in here, y equals 1. So the points of intersection are clear. One of them is -1, 1, and the other one is 2, 4. So now we are going to graph. For x squared, I don't need anything, but I'm going to plot these points first so I don't miss them when I graph. So these are the points of intersection. When I graph x squared, very simple. We graphed x squared many times before. So here is x squared. So this is y equals x squared. Now, in order to graph y equals x plus 2, anyone remembers which points are required when we graph a line? the x and y intercepts. So when x is 0, how much is y? Very good. So 0, 2 is the first point. So here it is. Good. Now when y is 0, how much is x? When y is 0, how much is x?
0.
-2.
Very good. So -2, 0. So here it is. And we know that they have to intersect. I already determined the points of intersection. This and this. And these are the x and y intercepts. So this is y equals x plus 2. Obviously, this is the area enclosed. That's the area I need to determine. Can anyone dictate what I should find? How do I find it, and what is the area? Equal to. How do we write it? Please give it a shot. Anyone, please. Maybe Allison or Erica or Mercy or Joan. I haven't heard from you in a long time. Maybe you want to try. Anyone? It's hard when I don't even know if my students are here. So? Yes?
If it A equals this, it's 59, -2 to,
Okay, the definite integral from -1 to 2.
Excellent. -1 to 2 from above, very good, minus, put parentheses so we don't make an error, if we have more than minus x squared. That's it. Of course, in this case it's one term. I really didn't need parentheses. Awesome. So then this equals to the integral from -1 to 2 from x plus 2 minus x squared dx. And we know all the steps now. X squared over 2 plus 2x minus x cubed over 3. And this is between -1 and 2. I will write the numbers. I have 4 over 2, which is 2, plus 4 minus 8/3 minus, put parentheses, 1/2 minus 2 plus 1/3. I'm not lazy to calculate this, but I don't want to waste the time in doing the arithmetic, and I allow you to do the same thing, of course. So we have math and 9, and the integral was from -1 to 2, and we have x plus 2 minus x squared. And of course dx. And when I click enter, I should get whatever this is, 4.5. So this is 4.5, and that is the area enclosed between the given functions. Which functions? Between x plus 2 and x squared. Okay? That's it. That's